Now, what if you wanted changes to data done remotely via another function? Well, that's what pass2 will be used for. So void pass2, and we're going to do passing by reference. So just like the previous program, let's go back here. Remember this? Right? So you need a pointer and you need to assign it to the address of data. It's going to be the same technique, except you're going to declare your pointer as a parameter, right? And when you pass, you're going to supply an address. And that's how it's going to work right here. So first, you need to declare a pointer, and let's call it dtptr. And let me just open curly brace, close curly brace, and right now leave it gutted. But the way you're going to call it is right here. So this is where it's going to become interesting. So pass2, you're going to have to pass the address of data, right? This is what we call passing by reference. And then we could do a printf to see what value did we get for data after we called pass2. And I'm going to try to alter data via dtptr, okay, to prove that, hey, I had direct memory access to the data, even though I was in a totally different stack, which is pass2, or stack means it's a chunk of memory space allocated to, let's say, a function that's running, right? And again, I don't want to get into a lot of details. I just want to show you how stuff works, right? So the details of it, that's another course. So the value of data after calling pass2 equals %d/n data. So we're interested in seeing what happened to data. So let's go ahead and do something under pass2. So let me save here, and we're going to go ahead and dereference dtptr. First, before I do that, let's just print what dtptr is looking at, right? So we could do something like this: printf dtptr is pointing to this data. Let's go ahead and %d/n, and then dereference asterisk dtptr. Remember, every time you dereference, you need to use an asterisk. Okay, and then we're going to alter data indirectly through this pointer. So how do you do it? Dereference the pointer. Okay, dtptr is going to be equal to, in our case, we're going to do 100. How's that? Okay. All right. So we know we're going to get 8 minus 8 when it displays here, since you altered it. I'm sorry. No, you're not going to get minus 8. Minus 8 only for the copy, right? So you're going to get 0 right here, right? You're going to get 0 when this displays. And then we're going to alter it to 100. When we come back to main, it will display 100. All right. So let's see the behavior of this thing. So let's compile and run. And sure enough, right? So the minus 8 had no effect because that was a copy. When you came back to main, you still had a 0. Okay? Now, in pass2, dtptr is pointing to data 0, which is fine because that you've given it the address of data, and data contains 0. Now, I altered it in pass2 and assigned 100. Lo and behold, what happened? When I came back to main, my data changed to 100. And that is the advantage of passing by reference, is that you can alter a value in another function, or a variable value in another function. So it gives you a lot more control. It can be also dangerous if you don't know how to use it, or you use it the wrong way. Okay? So this is important that you understand the difference between passing by value versus passing by reference. Every one of them has an advantage over the other, or a disadvantage. It all depends on your strategy. What do you intend to do? Okay, so now let's take it up a step further and do an example with arrays. Okay, and then we're going to do arrays and functions as well. So let's go ahead and do another program.